Hello, in these videos, we are going to look at how we can find the parametric equations that describe a circle. We have actually seen some of these before. I mentioned them in the first video that the unit circle is parametric equations. Well, if we have x naught plus a bt and y equals y naught plus a sine bt, this is going to be the circle centered at x minus x naught squared plus y minus y naught squared equals a squared. Centered at x naught, and has a radius of the absolute value of a. If b is bigger than 0, then the circle is generated in a counterclockwise direction. We can also get a clockwise direction by switching the sine and cosine. X equals x naught plus a sine bt, and y equals y naught plus a cosine bt will generate clockwise. And we saw that in an earlier example where we had 2 sine of 1/3 theta as x and 2 cosine of 1/3 theta as y. How this ultimately ends up working, again, showing the getting rid of the parameter. I have x equals x naught plus a cosine bt, and y equals y naught plus a sine bt. We can solve for sine and cosine by saying x minus x naught over a equals cosine bt, and y minus y naught over a equals sine bt. As we saw earlier, we know sine squared of an angle plus cosine squared of an angle equals 1. Well, that angle can be that bt, meaning x minus x naught over a squared plus y minus y naught over a squared equals 1. And multiplying both sides by a squared gives us x minus x naught squared plus y minus y naught squared. And there is our equation of a circle. So we can go back and forth. In our example, we want to find the parametric equation for a circle centered at 1, 4 with radius 2 generated clockwise. If the radius is 2, that means that is A. We have our center. This is x naught and y naught. And all we're told about B is that it needs to be greater than 0 to generate counterclockwise. I'm going to pick B to be 1 because we actually know the most information about if B is 1. So our parametric equations filling that in are going to be x equals 1 plus 2 cosine of t, and y is going to equal 4 plus 2 sine of t. We need enough t to create the whole circle. And in particular, this is going to be any interval of 0 to 2 pi. So it could be negative pi to pi. It could be 5 pi to 7 pi. The easiest one is 0 to 2 pi. And that is because we know in general, it takes 2 pi in our thetas to generate a circle. And that's because we picked b to be 1. If we picked b to be, say, 2, we would need from 0 to pi. If we picked b to be 1/4, we would need 0 to 8 pi. B controls how fast the circle gets graphed. But if b is 1, it's just our general circle. So plotting some of these points, if t equals 0, we would have the point 3, 4. When t equals pi over 2, we would have the point 1, 6. So 1, 6. When t equals pi, we would have the point -1, 4. And when t equals 3 pi over 2, we would once again have the point 1, 2 this time. And then back around to 2 pi will give us the point 3, 4. So here is our circle. It's generated clockwise. And when we went from 0 to 2 pi, we started at that 0. Notice it does have that correct center of 1, 4, as we've said it needed to. So there is our parametric equation to get the full circle generated counterclockwise. Part B says, what if we want to only find the lower half of the circle? Well, we can use the same equations. In fact, we should use the same equations. What we need to change is what is happening with t. We only want this lower half of the circle part. So I want to find the t values that give the lower half of the circle. And since we are generating counterclockwise, that starts at our pi value and goes to the 2 pi value. So if we just take from pi to 2 pi, and the same would happen on our unit circle, that gets the lower half of the circle. So pi is less than or equal to t is less than or equal to 2 pi. And we have our equation, our parametric equations for the lower half of the circle.